Welcome to the video lecture for section 6.3. This is for MSc 1105, College Algebra. My name is Jorge Gary Young. So in 6.3, we're going to evaluate exponential functions. We're not really going to graph exponential functions. I'm just going to briefly talk about the domain and range. We're going to define the number e, and we're going to solve exponential equations. So the first one, evaluate exponential functions. And so if st, a, and b are real numbers, and a is greater than 0 and b is greater than 0, then a to the s power times a to the t power is equal to a raised to the s plus t. If I have a raised to the s power and then raised to the t power, that's equivalent to a raised to the s times t. ab raised to the s power is equivalent to a to the s times b to the s power. 1 to the s power is equal to 1. A raised to the negative s power is equal to 1 over a raised to the s power, or 1 over a raised to the s power, and then a to the 0 power is equal to 1. And so an exponential function is a function of the form f of x is equal to c times a raised to the x power, where a is a positive real number. A does not equal 0, and c does not equal 0 is also a real number. The domain of the function is a set of all real numbers. The base a is the growth factor, and because f of 0 is equal to c times a to the 0 power is equal to c, c is called the initial value of the function. For an exponential function, f of x is equal to c times a to the x. Again, the restrictions is that a is greater than 0, a does not equal 1, c does not equal 0. If x is any real number, then f of x plus 1 over f of x is equal to a, or f of x plus 1 is equal to a times f of x. So some properties of exponential functions. Again, here, a is greater than 0, and a is between 0 and 1. Domain is a set of all real numbers. Using the interval notation, the range is a set of positive real numbers. There are no x-intercepts. The y-intercept is 1. The x-axis, y is equal to 0, is a horizontal asymptote as x goes to infinity. In other words, the limit of the function a to the x power as x goes to infinity is equal to 0. F of x is equal to a to the x power. A is between 0 and 1. It's a decreasing function, and it is 1 to 1. The graph of the function f contains the points negative 1, 1 over a, 0, 1, and 1a. The graph of f is smooth and continuous. It has no corners and no gaps. And this is what the function, or the graph of the function, looks like. Now the next thing is we're going to define the number e. And so the number e is defined as the number in the expression of 1 plus 1 over n raised to the n power as n approaches infinity. In calculus, this is expressed as the limit notation. So e is equal to the limit of 1 plus 1 over n raised to the n power as n goes to infinity. So as n gets larger and larger and larger without end, the function converges to e. And so here's the graph of y is equal to e raised to the x power. So the next thing we're going to talk about is solving exponential equations. So here, if I have a to the u power and a is equal to a to the v power, then u is equal to v. And that's a good theorem because it allows us to solve exponential equations. So we're going to go ahead and solve these two equations. We're going to solve 3 raised to the x plus 1 is equal to 81, and 4 raised to the 2x minus 1 is equal to 8 raised to the x plus 3. So in order to use the formula that we got at the beginning, we have to basically get the same base on both sides. So we can rewrite 81 as 3 to the 4th power. Since then the base is 3, I can just set the exponents equal to each other, which gives me x plus 1 is equal to 4 and x is equal to 3. For b, again, I have to find the same base. And so the base here turns out to be 2, so I can rewrite 4 as 2 to the 2nd power and 8 as 2 to the 3rd power. And then I can go ahead and multiply those exponents or combine like terms on each side. So I end up with 2 raised to the 4x minus 2, and then 2 raised to the 3x plus 9, which is this line over here. Then I can get rid of the bases, right? Because this conclusion here allows me to do that. And then here, when I solve for x, I get x is equal to 11. So here's another example. We're going to go ahead and solve e raised to the negative x squared is equal to e to the x raised to the 2nd power times 1 over e to the 3rd power. So what we do, we're going to use the law of exponents first to get a single expression with the base e on the right side. And so the right side then becomes e raised to the 2x minus 3. Again, since I have the same base, I can go ahead and eliminate the base by property 3. And so I end up with negative x squared is equal to 2x minus 3. I'm going to go ahead and this is a quadratic equation, so I'm going to write it in standard form. I'm going to factor that, so I get x plus 3 times x minus 1 is equal to 0. So using the zero product property, x is equal to negative 3 or x is equal to 1. And that's the end of 6.3. Thank you.